Okay, so this is Unit 1.1 Video C, and what we're going to look at is we're going to be looking at interpreting algebraic expressions and how that kind of works when we're dealing with story problems or word problems, so that we're going to kind of look at the basis for understanding verbal cues for algebraic expressions and how we can start to write expressions and how we can write equations and all these different things based on some of the trigger words and things like that we are given of that problem. Now, first, before we kind of get into anything, we're going to look at trigger words. Now, trigger words for math basically are going to be the words that tell us when to multiply, when to divide, when to use fractions, when to use addition, subtraction, and basically all of those other things that we might be running into. And we'll get into that a little bit more, but we're going to kind of start at the basis. Whenever you see multiplication, we're going to look at words like by. You can look at words like multiply. Sometimes you can see of as one of those words that would say that you need to do any kind of multiplication. When we look at division, we're looking at parts. So anytime something talks about splitting things into parts, so you're trying to break things down or distribute things evenly, those are times that we can use division. Fractions, whenever you're dealing with rates or ratios. So in the past you have worked with rates and ratios, and so when you see those kind of words, when you talk about miles per hour or you're talking about words per minute or any of these things, those are sometimes when you're going to be using fractions, and those can help you build some of those things so that you can draw pictures and you can set up scenarios of when to use these things. Addition, sometimes you can think of it as pretty easy. You can say plus. A lot of times you'll see the word and you'll just sometimes see addition or with or some of these other words that might mean addition. You might see for subtraction less, or we could talk about fewer. Anytime that you see these things where you're trying to take away, or words like drops, or words that might indicate being negative, up and down are good words for addition and subtraction, where things are going up for addition, things are going down for subtraction. And then for equals, a lot of the time what you'll see is the word is. Anytime you see that word is, that's basically telling you that we need to compare it to something, or use as a comparison to say, as something is happening, it's going to be this, or it's going to be is 45 or is 10 feet or something of that nature. So just kind of be on the lookout for all the trigger words that you've learned, not just necessarily the few that I've given you here, but there are trigger words all over the place, and we'll talk about those as we come across those too as well. And so one of the example that we're going to look at is specifically an expression, and the expression that we're going to use is as follows. And so it's 0 or negative 0.3y plus 61. That models the percent of eligible voters who voted in a presidential election from 1960 to 2000. So basically someone was coming up with, how many people are actually voting that are eligible to vote, so that they can start making predictions. And so in the expression, y represents the number of years. And so what we're always trying to figure out is, we're looking at the variables and we're looking at the different pieces and what they could potentially mean as we're trying to do something. And so basically what we have is that y represents the number of years since 1960, and we need to find the approximate percentage of eligible voters who voted in 1988. So we're basically going to look at the past and say, okay, how many people were actually voting? And so we're going to go over a couple of things as we try to get to the answer of this in just a second. So the first thing is I just rewrote up the problem there for you and rewrote the expression. And so a couple of questions that we want to look at is, when we're looking at a story problem, it's always best to identify in something as in simplest forms as possible. And we'll kind of get to that in a second. So what is the variable, and y? And y represents, and I'll put this in parentheses, it's a year. It's number of years. So when we're looking at a variable, one, identify what it actually is in the expression, so what the letter is, and then what it actually represents. We're looking for a years, and so whenever we're given expressions, everybody always wants to put a number in there, and so the number that we're going to be looking for is a number of years since 1960. And so let's answer a couple other questions. So which term depends on the number of years that have gone by? And so this idea is this one right here, and we know that because it has the variable in it. So it depends on the variable. So I won't know anything until I tell it a particular variable. The term that does not is this 61, because if you remember anything about expressions, this is the constant. It doesn't change. There's no variable associated with it, so it doesn't depend on anything. It's just some random number that was part of the original expression. So one of the things that you need to do when we look at expressions, and especially with story problems, is look at the different parts. What does each different part mean, and what will it bring to the overall expression? And so what I like to look at is, what is the purpose of these things? So when I look at a story problem, when I look at a basic expression, I want to look at it in terms of what is each purpose? What is it doing? What does it stand for? What should I plug in? All these different things. What's positive? What's negative? Why is it positive? Why is it negative? And so the purpose of this constant term, so when we look at 61, that basically is going to tell us is that's kind of an initial value. And so when we look at this, this is percentage of voters. So the idea is that 61% that's kind of our baseline. It started at 61. It can either go up or it can go down as years go on. And so when we look at the sign, when we look at what potentially could be changing, this 0.3 is negative. And so since it's negative, what we should think of is this should be going down. And so for us, this means that fewer and fewer people will be voting every year. So it's going to start at this baseline of 61% and just kind of go down from there. So if we're starting at 1960, every year it should be a little bit lower, a little bit lower, a little bit lower than 61. I'll never go above 61, and I haven't even done anything yet because I identified that 61 is kind of a baseline, and that since the term that has the variable in it is negative, my value should be going down. And then finally, what should I be plugging in for y? Well, it should be a year. Well, years since where I started. I started in 1960. So 1960 is basically my year 0. So year 0 is 1960. And then I want to go, so 1960, I want to go to 1988. And so the idea is how many years have passed? Well, I can just do some simple subtraction. 1988 minus 1960 gives me 28 years. So basically what I'm going to be doing is I'm going to be plugging in 28. And so if I go ahead and do that, negative 0.3 times 28 plus 61. And that would give me my answer. So, and all the idea of what we're trying to do here is trying to figure out in simplest form what is happening, what is all these different pieces contributing. Should it be going up? Should it be going down? And all this kind of stuff. So if we go ahead and we do this multiplication, so this piece contributes negative 8.4 plus 61. I add those two things together and I get 52.6%. So just like I said, since those 28 years have passed, I've lost about 8% of my voters every year. And so by the time I get there, or not every year, but since then, and so I'm down to 52.6% of my voters. So based on this model, and again, like I said, because it's negative, I should be expecting these to go down. If for some reason I got something bigger than 61, I would have to go back and I would have to look at what I did. So it's important to kind of estimate what you think you should be getting before you get your answer so that you can kind of fact check it to make sure you're doing what you're doing is right. Okay, so I can basically take that same idea and I can apply that for anything else that I want to. So if I wanted to give you any particular year, say 2014 or 2020, you could use this same model and you could just keep applying in the same way. So remembering that y is the years that we have from 1960, we can just basically do some basic math and we can figure out what we would need to plug in for y. So if I was going to do 2014, my y would equal 54, so I can just subtract those. If I wanted to do 2020, my y in this case would be 60, and you can go ahead and plug those in as you want to. So 0.03 times 54 plus 61, and then the other one would be negative 0.3 times 60 plus 61. And so when we kind of do all that operations, we get a value of 44.8% in 2014, and then the other one would be 43%. And again, that follows along with what I said before, when every time that we do this each year in the future, my voter percentage turnout should be lower and lower and lower. Now that's just kind of the basic starting point for our story problems or our word problems. But a couple of things that I like to look at is, try to simplify the context. Take away all the fluff. Try to give a 5 to 7 word explanation, if you can, about what the problem is asking for and what's the basic scenario. If you can give me a simple context to it, it'll help you understand exactly what the root of the problem is and where to find the solution. And then what is the most basic answer to the question and what it's looking for. If I was to look at that last question, I want percentage of voters who actually voted. And so when I look at that, I'm looking for a percentage. And when I'm looking at specific things and I'm trying to understand the context, like I said, try to make it as simplified as possible so that you can look at the most simplified answer when you're trying to come up with context. Okay, and so that's going to do that for this particular video.